Hello everyone, I'm Yasser Saeed and this is the course of International Trade Theory, Econ 446, and today we are going to study Heckscher Ohlin theory of trade. So here is what we are going to study in this lecture. We will start with the production possibility frontier and we will compare this production possibility frontier with the one that we studied earlier in a single factor of production, that was the labor in David Ricardo's model. Then next we will see the relationship among output prices and the input prices, or what we call the prices of the factors of production, the wages and the rents, and the level of inputs. Again, the relationship among the output prices, the input prices, and the level of inputs, the amount of factors of production that we are going to use, and we will see how much we can produce with those levels of input. Then we will see how can we trade in this type of model, the trade that is explained by the Heckscher Ohlin theory. And finally, we are going to see the impact of such type of production on the income distribution. Does this theory explain the variation in income distribution within a country? Some people may benefit more as compared to the other group. So we will study that in our lecture. Heckscher Ohlin model basically follows the theory of labor productivity, or also known as the theory of comparative advantage. Comparative advantage theory tells us that countries trade because they have comparative advantage in certain goods, and that advantage occurs because of the difference in labor productivity. Means that in some country labor are productive in producing cheese, whereas in other countries labor are productive in the wine sector. So because of their difference in labor productivity, they are able to produce abundantly certain goods and then trade with each other. Heckscher-Ohlin theory basically does not rejects the comparative advantage theory, rather aids to it. What Heckscher-Ohlin theory believes in is that it is not only the labor productivity that matters, but resource differences matters. In each country we have different resources, and that enables a country to trade. For example, if we look at Saudi Arabia, they are not rich in agricultural lands. They have a limited cultivatable land, but they have abundant oil resources. So, Saudi Arabia will trade in petroleum products, and this is not because their labor is efficient in oil producing, but rather than they have abundant oil resources. Similarly, if you look at Pakistan, we cannot produce oil at that competitive level because we do not have sufficient oil resources, and comparatively we have abundant agriculture lands available to us. Therefore we produce agricultural goods and Saudi Arabia will produce petroleum goods, and both these countries will trade with each other. So basically, Heckscher-Ohlin theory argues that not only the difference in labor, but the labor skills, the physical capital, the land, or other factors of production across countries create this productive difference. Countries have relative abundance of factors of production. Some countries are abundant in land, whereas other countries are abundant in labor, and some countries might be abundant in capital. So all countries have different level of abundance in different factors. And again, production processes use factors of production with relative intensity. It means relative intensity basically means that in some countries labor in some countries labor will be used more as compared to capital, whereas in certain countries we will be using capital more as compared to labor. It depends entirely on the abundance of these capital, of these resources. So, when we want to discuss the Heckscher Ohlin model, there are a set of assumptions that need to be understood first, and these assumptions are that we have two factors of production for the model. One we call the labor, and the second factor of production, that is land. We are ignoring all other factors of production such as capital and entrepreneurship. Then the second assumption is that the amount of labor services and the land varies across countries. Means labor and land will be in different quantities in different countries. They cannot be the same. There will be more labor in one country and more land in another country. Then the third assumption is that the quantity of land and labor will remain fixed in those countries. The total labor available in Pakistan will not change, and similarly, the total amount of land in Pakistan will not change, it will remain constant. Similarly, it will not change in the other country that we are studying. This amount will be fixed. And remember that this is only an assumption. We may relax this assumption in order to understand the impact of these these factors of production. What if we increase the factor of production in a country? What will happen? So for that purpose we can relax this assumption, but the model overall assumes that this factor of production will remain constant. Then again, two goods will be produced, and we name those goods as clothes and food. No other goods will be produced in this economy. How will the price be determined in this economy? Basically, the prices are determined through competition, and whenever we use competition, we means supply and demand. So, how will wages be determined? Wages in an economy will determine through supply of labor and demand of labor when they wherever at whichever point they are in equilibrium, that will determine the amount of labor utilized in that economy and the wages that will be given to them. Similarly, it is true for land. The rent of the land is also determined through competition, through the supply and demand forces. And our final assumption for this model is that only two countries are model, and we name those two countries. We call one domestic country and the other we call foreign country. So basically, if you look at these assumptions, what you see that we have two factors of production, and then only two goods are produced, and only two countries are modeled. So this model, the Heckscher Ohlin model, is also called cross two model. The production possibility frontier in our previous model was a straight line. For example, we had two goods. One we call clothes and the other we call food. PPF was a straight line sloping downward. But now the production possibility frontier will not be a straight line, rather than it will be a curved one. It will be curving towards the outside. So what is the basic reason for that? It is because Previously, we were using a single factor of production, but whenever we are using two factors of production, then marginal productivity of labor and marginal productivity of land both will come into work. The more you utilize land, the more the quantity of food will decline with the passage of time. Anyhow, we are going to discuss it in the coming scenarios. So let us first define some of the variables that we are going to use here. The first one is ATC. ATC is basically the hectares of land. T represents land, or alternately we call that terrain, whereas C represent uh, its usage for the production of cloth. Similarly, the ALC represents labor used for the production of cloth. Labor hours used for the production of producing 1 meter square of cloth. Again, we define ATF as hectares of land used for production of 1 calorie of food, and ALF as hours of labor used to produce 1 calorie of food. L is the total amount of labor available for the production, and T is the total amount of land or terrain available for production. Remember that we have discussed in our assumption that the amount of L and the amount of T in the economy will remain fixed. It is important to note that for the production possibility frontier, both the factors of production are required. We will be using land as well as labor in order to produce the amount of cloth required and the amount of food that we require. So the basic equation for the total allocation of land resources is given as ATF into QTF plus ATC into QTC, which should equal to T, and it will be less than T in case we are not utilizing the entire land for the production of these two goods. But if we are using the entire land resources, then it will equal to T. Basically, ATF shows the amount of resources, the land resources for the production of food, and ATC into QC shows the amount of total land used for the production of cloth. Combining these two gives us the total amount of land that has been utilized. We can do the same math for the labor. Total labor utilized for production of food and total labor used for production of cloth, and this gives us the total labor utilized in our production. Now we need an important assumption regarding the production possibility frontier. Since we have two goods, one is called cloth and the other one is called food. Now the nature of these two goods is different. We consider cloth to be labor-intensive good, meaning that when we want to produce a unit of cloth, we need more labor as compared to land for its production. And for food, we need more land rather than more labor for its production. So we say that cloth is labor intensive and food is land intensive. The equation we can use for this purpose is ALC or ATC, which is greater than ALF or ATF. Let me rewrite this equation so that we can understand the statement more clearly. You know that ALC is the amount of labor required for the production of cloth, and we compare it to the amount of land required for the production of cloth. So this amount overall is greater than the amount of labor required for the production of food as compared to the amount of land required to the production of food. The equation simply means that labor requirement for cloth is more as compared to labor requirement for food. The assumption influences the slope of production possibility frontier. Now, when we want to produce cloth or we want to produce food, we can substitute the amount of labor for the production of cloth with certain amount of land. But let's assume that we are not able to substitute these two factors of production. If that is true, then we will get two independent production possibility frontiers, such as you see in the graph. Uh, the one is for labor and the second one is for land. How much we can produce depends on the slope of these individual constraints. Now the green area shows us our production possibility frontier. This is what we can produce. The red area also is producible, but that production is inefficient. So in such scenario, what we get a kinked production possibility frontier, and this kink is usually inwards. The production possibility frontier is different when the factors of production are substitutable. In this case, we get a curved production possibility frontier. Now, why is it a bow shaped? The basic reason for that is that now we have two factors of production, and when keeping one factor of production and increasing the other factor, we have a decreasing marginal productivity. For example, we have factor of production of land and we have the total output of food QF. Now when we increase the amount of labor while keeping the amount of land constant, what happens? Our productivity increases, but as we increase more and more labor, our marginal productivity is declining. This marginal productivity, this decline in the marginal productivity of labor causes the kink shape. As we have discussed, we can use multiple combinations of input, that is the land and labor, to produce a single unit of food. But remember that this combination is not constant. For example, we may we may sacrifice 1 unit of land and we may substitute that with half unit of labor initially. You see, we may substitute that with half unit of labor, but the more and more we substitute it with labor, we may ultimately need to change 1 unit of land with 3 units of labor. So the point is, in the production of each unit of food, unit factor requirement of land and labor are not constant. And you see, it is apparent from the graph that the slope is not constant. It is not a straight line. Isocont is not a straight line, but its slope varies as we try to use different combinations of land and labor. Now the production possibility frontier tells us what we can produce, but it does not tell us the worth of that production. Let me draw the production possibility frontier here. For example, we have food on the y-axis and cloth on the x-axis, and we have a production possibility frontier. We can produce anything within this red line. Let me mark that with blue. We can produce anything in this area. We cannot produce anything over here. On the red area, we cannot produce anything. But if we want to produce efficiently, we'll be producing over the production possibility frontier, and we can have multiple points on the production possibility frontier. For example, this is point A, point B, and point C. All of these can be produced, but what is the worth of these points? What is the worth of these combinations of code? They will not remain the same. So we need to understand them. The production possibility describes the economy can produce, but to determine what the economy does produce, we must know the prices of these goods. In general, the economy should produce at the point that maximizes the value of production. If the value of production is maximum at point A, we will produce at point A. If it is maximum at point C, we will produce at point C. Otherwise, if it is maximum at B, we can produce at point B. How we know the value of production? It is given by the equation V is equal to PC into QC plus PF into QF. The overall value of production depends on the prices of cloth and the prices of food. The overall value of cloth is PC into QC. Price of cloth multiplied by the amount of cloth that we have produced, and then PF into QF tells us the overall value of the food that we have produced. Combining these two gives us the overall value of our production. So basically it depends on the values of the PC and PF. PC represents here the price of cloth, PF represents here the price. Using the same equation, we can derive the ISO value line. What is an ISO value line? It represents a constant value for a specific production. So let us go back to the main equation that we have discussed now. V is equal to PC into QC plus PF into QF. Keeping its value constant, we may write it in terms of quantity of cloth or quantity of food. So taking food to the left hand side and keeping the rest of the equation on the right hand side, taking V to the right hand side, we have our new equation as PF into QF equals V minus PC into QC. And again, dividing both sides by PF, we get QF and V over PF minus PC by PF QC. So this is a straight line. We get a straight line for ISO value where value remains constant, and minus PC by PF, it is actually the slope of this line, whereas V by PF, this is actually the intercept. V by PF will be the intercept of our ISO value line. Let us integrate this ISO value line into our production possibility frontier. Our first ISO value line, let us call that V1. This is possible, we can produce anything on V1, but this will be an inefficient production because it falls below the production possibility frontier. Let's say if we produce at point A, we are not utilizing our entire resources. Again at point B, we are using more resources than before, but again this is not efficient. At point C, our production possibility frontier is at its maximum. But what is wrong with point C? We are not producing the quantity that gives us the maximum value. But if you look at point Q, we have maximum value as well as an efficient production. Again, anything above that, let us say that we want to produce at point, uh, we call it F. At point F, we are unable to produce. The value is more as compared to point Q, but that is beyond our production capacity. We do not have enough resources to produce at point F. What we can summarize from this discussion is that given the prices of output, a point on one ISO value line represents the maximum value of production, say at point Q. At that point, the slope of the PPF equals the slope of the ISO value line, and the slope of ISO value line is given by minus PC or PF, and this is also our opportunity cost. Our opportunity cost must equal to the relative price of clothes as compared to the relative price of food. In other words, the trade-off in production equals to the trade-off according to the two important key points that we have studied up to this point is that country will produce on its production possibility frontier because that is efficient production, and they will produce equal to the relative prices of the two goods, that is on the ISO value line. And the third important decision is, in order to produce that amount, how much of the factors of production are required. So they depend on the price of factors of production, and price of factors of production basically are the wage given to the labor and the rent given to the landowners. So again, it depends on the market prices of the factors of production. If wage rates are high and lending rates are low, land rates are low, then firms will use more land as compared to labor. So this is enough for today's lecture. In the next lecture, we will continue with the remaining of the Heckscher Ohlin model.